first, draw the cosine graph. Now I'm going to draw this graph whenever I can, because you have to get used to it, and you should also try to draw this graph as many times as possible until this just becomes natural. If you can just close your eyes and imagine this graph, even these x values, then you don't have to draw it. But unless you're that much comfortable with this graph, you should always try to draw it until this becomes very natural for you. Okay? Alright, so for this graph, you have to know that at each of the quadrants, there are like three special angles where the value is one of those special values, right? Okay. And then, let's see, what's pi over 6? Pi in degrees is 180 degrees. So if you divide 18 by 6, you get 3. So this means it's 30 degrees. So it's definitely between 0 to 90 degrees, and you have to know that the special angles are 30, 45, 60. Which means you're looking at the 30-degree one, the very first guy right here. Okay. Now, is this small or medium or large? It's the large one compared to the other two. This is the largest, right? And I spoke about how it's very easy to remember these values because those are as easy as 1, 2, 3. They all look like square root of something over 2. And the numbers that go inside the square root are very easy to remember because it is literally 1, 2, 3, right? And the 3 is the guy that's the highest number. So that's going to be the answer for this. Okay. So I've been calling these 3 numbers as small, medium, and large. And if you use that terminology, it's easy to look at this graph and figure out the value. Now, when you see such a question on the exam, I am going to require you write down the exact answer. So, of course, you can plug in pi over 6 into your calculator and get some approximate value, but that won't be given any credit at all, okay? Because that punching in can be done by anyone. You actually have to know which of these 3 values the value of the function is equal to. Okay, now let's move on to the next question. What is secant? Does anyone know? Secant is 1 over cosine, yes. So you have to know that secant is 1 over cosine of pi over 6. And by the way, let me just write over here, maybe, no. Let me write over here. So, secant of x is 1 over cosine of x. Cosecant of x is 1 over sine of x. And then cotangent of x is 1 over tangent of x. Okay. These are called reciprocal functions. If you take the reciprocal of the sine, cosine, tangent, you get the secant, cosecant, and cotangent. Okay, so that's why I'm writing down secant of pi over 6 is 1 over cosine pi over 6. We already know the value of cosine pi over 6. We have it here. It's 1 over square root of 3 over 2. Which means it's the reciprocal of radical 3 over 2. So that's same as 2 over radical 3. However, I am also going to ask in the question to rationalize the denominator if it's necessary. So if you just stop here, you're not going to receive full credit. you still have to multiply by square root of 3 top and bottom. So that square root of 3 squared in the bottom will give you 3, and the numerator will be 2 times radical 3. So that's going to be your answer for this second. Alright, now let's move on to tangent of pi over 6. How do you compute tangent? Tangent is equal to?
Opposite of adjacent.
Okay, you can do that, but there's also, well, if you use, if you have a triangle with hypotenuse 1, what is this length?
Adjacent.
Now, if this hypotenuse is 1, we know that this length is cosine theta, and this length is sine theta, right? So according to this picture, we know that tangent theta is equal to sine over cosine, right? So tangent is same as sine of pi over 6 over cosine of pi over 6. Okay, we already know the value of cosine pi over 6, but we don't know the sine pi over 6, so let's try to draw the sine graph. 2 pi, pi, pi over 2, and the midpoint between the two is you add these. Pi plus 2 pi is 3 pi, and you divide it by 2, that's how you get the midpoint. You get the average by adding two numbers and dividing by 2, right? Once you get these x-coordinates, you do 0, 1, 0, negative 1, 0. That's the graph of the sine. And remember, pi over 6 is 30 degrees. We talked about here. So we're looking for the sine value at 30 degrees. Okay, looking at this, what do you get? Do you have small, medium, or large? Small. So what's the value of sine pi over 6?
Radical 1 over 2.
Yeah. Radical 1 over 2 or just simply 1 over 2? Because square root of 1 is 1. Right? And then we already know that cosine pi over 6 is radical 3 over 2. How do we simplify this?
Keep changing.
You can do keep, change, flip, or you can also multiply by 2 top and bottom, which is the method I prefer. Because this applies in more circumstances than keep, change, flip. So I like this better. So these cancel, which gives you 1 on the top, radical 3 on the bottom. Okay. What next? What should I do next? Multiply square root of 3 top and bottom. So that would be square root of 3 over 3. Okay, next question is tangent negative pi over 6. And I want to point out something about tangent and also some other tricks to make the solution to D simpler. And I want you to look at the following picture. If this is theta, then what's negative theta? Negative theta is same amount but going in the opposite direction, right? So this would be negative theta. Now, you know that the y-coordinate of this point is the sine of theta. Y-coordinate of this point is the sine of negative theta. And if you compare the two triangles, this length and this length, these two lengths are the same because they're both right angles and they have the same angle here, so these are congruent. You might have learned such a thing in high school geometry, right? So if they share the same side here, the same length, and then if these two angles are same, then it's ASA congruent. If these are congruent, then we know that these two sides are exactly the same sides, but one is going up, the other is going down. So what's the relationship between them? sine theta is equal to
Negative.
negative sine negative theta. Let me do it the other way. I want to say that sine of negative theta is same as sine theta, but with the opposite sign. Okay? One goes up, the other goes down. Now, what about the cosine? Cosine negative theta should be using this reference triangle, and it's the x-coordinate of this reference triangle, so it's really this length that's cosine negative theta. But what about the cosine positive theta? Cosine positive theta uses this reference triangle, and it's this base length. Oh, so it's the same. They're exactly the same. So you can see that while for the sine, minus comes out like that, the cosine eats up the negative sign. They satisfy very different identities. And if you have a function where the minus can be brought outside, such as this, you call such a function an odd function. And if a function eats up the negative sign, you call such a function an even function. Okay? I spoke about these graphs. You can also use such a graph to argue for these two. So first of all, if I take the sine graph and copy this much over here, copy and paste it over here, then you see that if this is theta and this is negative theta, one goes up, the other side goes down. Right? So again, from this graph you see that sine of negative theta is same as negative sine theta. On the other hand, if you take the cosine graph, I drew this a moment ago, if you copy this and paste it over here, this is what you get. So this is the cosine graph. And if you compare the positive theta and negative theta, they're exactly the same value. If one's positive, the other's positive as well. Right? So you see that even from the graph, you can argue that cosine negative theta is same as cosine theta. Now, what about tangent? Well, because tangent is sine over cosine, sine of negative theta over cosine of negative theta, that's what you're going to get. And because sine negative theta, negative comes outside, whereas cosine negative theta eats up the negative, so this is just cosine theta. And if you just look at this much, that's just tangent theta, so you end up with negative of tangent theta. Which means tangent also is an odd function. The minus inside the tangent, you can bring it outside. Okay? And make it like that. So that's, again, an odd function. Now, if you know this, then questions like this becomes really simple because I see a minus, I can bring it outside because tangent is negative. Tangent is an odd function. And we've already worked very hard to figure out what tangent of pi over 6 is. It's radical 3 over 3, so you end up with this. Okay. So this question D would be simple if you knew this identity. What's the period of cosine theta? Cosine is not just from 0 to 2 pi like this. This actually repeats, right? So you copy and paste this much left and right infinitely many times. That's the full cosine graph. So one period or one cycle of cosine is this much, and this length is what we call the period. Okay, so what's the period of cosine theta?
2 pi.
2 pi, 0 to 2 pi, so it's 2 pi. The length is 2 pi. Now, what about this 1/4 cosine theta? What does this 1/4 do? What? It shrinks in which direction?
Vertically. No.
Not. It'll be vertically. You'll squash it this direction. So
still 2 pi.
it's still 2 pi. Yes. So what's happening is it's still 0 to 2 pi, but instead of going from -1 to 1, it shrinks down to 1/4 and -1/4. So the graph goes like this. But this gets copied and pasted left and right. So this length is still just 2 pi. The period is again 2 pi. What about this 1/4 inside? What would this do? Well, it expands. Yeah, it does the opposite, okay? So this thing would actually go until 4 times 2 pi, which is 8 pi. Okay? And then you get 1 and then -1. That's what you're going to get. So it'll be 8 pi. Now, one of the formulas that I discussed in class was that period is equal to 2 pi divided by a, where a is the coefficient of x, in our case theta. So this is 1/4. So you can also get the same idea, same answer, by instead of thinking of transformations, you can just take 2 pi and divide it by 1/4. Division by 1/4 is multiplication by the reciprocal, which is 4/1. And 4 times 2 pi is indeed 8 pi. Okay? And if you apply the same logic here, the period would be 2 pi divided by 8. And if you reduce top and bottom by dividing by 2, you get pi over 4 as the period for the last one. Okay, so sketching requires you to know the amplitude and the period, and also this third thing called phase shift. This one doesn't have a phase shift, so we'll go to the next question to discuss the phase shift. All right, so what's the amplitude here?
4.
Amplitude is this coefficient in the front, right? That's 4. What's the period? Formula is 2 pi divided by whatever that's in front of x, right? So this number, we're going to call this small a. So it's 2 pi over a, which is 2 pi divided by 2 in our case. That's going to be pi. Okay. So how do we draw the graph? Well, you can start to draw the graph by using the usual sine graph. That's the usual sine graph, right? Yeah. Remember, this is the sine graph. The cosine graph is like that. You have to remember those two graphs, okay? Cosine and the sine. Never forget these two. So this is one period of the sine graph. And because there's no phase shift, it will start at 0. Now the next example will have a phase shift, and that's where the graph will start for the next one. But this one doesn't have a phase shift, so it starts at 0. And where would it end?
Pi.
This length we just found out to be pi, right? So this will end at pi. How high does it go?
4.
Positive 4 goes down to negative 4. Okay. So this is obviously not drawn to scale because pi is 3.14. 4 is bigger than pi. So if you drew this in a graph that's drawn to scale, you'll have much taller graph than wide. But that's okay. I mean, as long as you put these coordinates correctly, then it's fine. Okay. Now, on the exam, I'm going to ask some additional questions, which is like, where are the zeros? So for example, what's this coordinate? How would you know this coordinate?
It's the midpoint.
It's the midpoint between 0 and pi, right? How do you find midpoint? Add the two numbers and divide by 2, right? So what do you get if you do that? Pi over 2. Okay, what about this point? There'll again be a midpoint, right?
Yep.
So what would this point be?
Pi.
Pi over 4, right? So this point will be pi over 4 comma 4. So that could be a question. Find the coordinates of the maximum point. Okay? So that could be a question. What if I ask you for the minimum? Well, if I ask you for the minimum, then now you have to calculate the midpoint between pi over 2 and pi. That takes a bit more work because you have to now add pi over 2 plus pi and divide it by 2. right? And yeah, because we're taking average. The averages means you add the two numbers and you divide by 2. That's how you take average. Just like if your exam 1 was 70, exam 2 was 90, what's the average? 70 plus 90 and you divide by 2, that's 80. Right? That's the midpoint between 70 and 90. Yeah. So that's what we're doing. In order to add fractions, we need common denominators. So I multiply 2 top and bottom. So 2 pi divided by 2 is the same as pi, right? And then pi plus 2. Now that they have common denominators, I can just add pi and 2 pi, which gives you 3 pi divided by 2. And then dividing by 2 is same as multiplication by 1/2. So that gives you 3 pi over 4. And that tells us that this point right here would be 3 pi over 4, comma, what's the y-coordinate? Negative 4. Just like that, okay? All right. This is a bit more challenging now because this has phase shift. But nonetheless, the other parts are easy. Amplitude is what?
3.
3. What's the period? It's 2 pi divided by 2, right? So it's going to be pi again. How do you get the phase shift? You set this thing inside to be 0. That's the phase shift, right? Whatever that's inside, you set it equal to 0. That gives you the phase shift. And then 2x is equal to pi over 3. Divide by 2. But division by 2 is same as multiplication by 1/2. So it's going to be pi over 6. Pi times 1 is pi. 3 times 2 is 6. Okay, so that's your phase shift. Now, how do you make use of this to do the graph? Well, you have to start with the cosine graph, so let's draw the cosine graph first. And we have to make sure that it starts at pi over 6. Because that's the phase shift. Phase shift starts at pi over 6. And I know that 1 full period is what? Pi. Okay, that means where does this end? How do you know this point? How do I calculate this point? What should I do?
The parentheses equal to 2 pi?
No. Oh, okay, yeah, that's one way to do it. You can set this one equals to 2 pi and solve. That will be another way to get this point, okay? Yeah. Yeah. Good, good. I forgot about that. I explained that during the class as well. Yeah. But there's another way. If this is pi over 6 and the length is pi, how would you get this point? Add pi, right? So you have pi over 6. You add pi. Well, pi is 6 pi over 6. I made common denominators. And then you have 7 pi over 6 as this point. 7 pi over 6. Again, you should be ready to figure out the zeros or this bottom point. You have to know those coordinates. And all you have to do is know how to calculate midpoints. Right? So let's just figure out this one. Okay. So what if the question on the exam asks for the coordinates of the minimum? Okay, what should I do? Yes. You add these two endpoints, this point, divided by 2. Since they have the same denominator, I just have to add the top, which is 8 pi, divided by 6 over 2. And then 8 and 6 reduces to 4 pi over 3. Dividing by 2 is same as multiplication by 1/2, which is 4 pi over 6. And then you can reduce this further and rewrite it as 2 pi over 3. So we know that this point here is 2 pi over 3. And therefore this coordinate would be 2 pi over 3 comma, oh I forgot the y coordinate. How high does this thing go? 3. How low?
-3.
Negative 3. So this point will be 2 pi over 3 comma negative 3. So when it's just a graphing question, you definitely have to give me the coordinates of the beginning and end, and top and bottom, right? But then additionally, I might ask for some of the other coordinates. Okay. What's the amplitude?
It's 2.
It's positive 2. It's not negative 2, it's positive 2. Okay, you always take the absolute value of the coefficient. What's the period? 2 pi divided by 3. Okay, how do you get the phase shift? Set 3x minus pi over 2 equal to 0. 3x is equal to pi over 2. Divided by 3, you get x equals to pi over 6. Because dividing will end up multiplying 3 in the denominator. Okay? So these are the ones that you get. However, you still need to know how to handle this minus. What this, yes? It flips upside down, right? Good. So what you have to do is, instead of drawing the usual sine graph, you don't do that. You have to flip it upside down. So you're to draw the graph, sine graph upside down, just like this. Okay? And you're going to say the graph starts at pi over 6 because that's your phase shift. Pi over 6 is positive, so the actual y-axis will be somewhere here. Okay. Now, how high does it go?
2.
2. Amplitude is 2. How low does it go?
Negative
2.
2.
All right, what is this coordinate? How would you find that coordinate? At 2 pi over 3. That's the period. Okay, so you start at pi over 6. One full period is 2 pi over 3. So you're going to take pi over 6, add 2 pi over 3. And you get pi over 6 plus, you multiply 2 top and bottom, you get 4 pi over 6, which gives you 5 pi over 6. Okay, so that's going to be 5 pi over 6. Okay, this time let me give you a challenge. Find the coordinates of this highest point. Try that. It's really just the midpoint of the midpoint. So you have to calculate the midpoint first, and then calculate another midpoint. First, we look for this midpoint. Midpoint is average. So you add pi over 6 and 5 pi over 6. And divide by 2. Same denominator, so you just have to add the top. Pi plus 5 pi is 6 pi. Divided by 6 over 2. And 6 cancels, so you just have pi over 2. Okay, so we've identified that this coordinate is pi over 2. Now we have to look for this midpoint. How do you do that? You add the 2 and divide it by 2 again.
That's why you have divided.
So it'll be pi over 2 plus 5 pi over 6 divided by 2. And we need common denominator, so we should multiply top and bottom by 3. 3 times 2 is 6, right? So it's going to be 3 pi over 6 plus 5 pi over 6 divided by 2. That's going to be 8 pi over 6 divided by 2. Or let's rewrite this as times 1/2, right? So multiplication is top to top, bottom to bottom, so it's 8 pi divided by 12. But now we see that both 8 and 12 are divisible by 4, right? So it's going to be 2 pi over 3. 8 divided by 4 is 2. 12 divided by 4 is 3. Okay, so what does that tell us? It says that 2 pi over 3 is the x-coordinate, and we already know that the y-coordinate is 2. So this coordinate is 2 pi over 3 comma 2. All right? Okay, let's think about the following. For what x values is secant of x undefined, where x is between 0 to 2 pi? to understand what this question is asking, you first have to question what secant of x means. What is secant of x? It is 1 over
Cosine x.
cosine x, right? So secant of x is 1 over cosine of x. And if you knew that, then the question makes sense, because when you have a fraction, whenever the denominator is 0, the fraction is undefined, right? So now the question is, when is cosine of x equal to 0? Okay, hopefully if you can picture the graph of cosine, then the answer is just obvious. But because a lot of you are still trying to get used to this, let's try to take some time to draw the cosine graph. 2 pi, pi, pi over 2, 3 pi over 2. The graph of cosine goes like 1, 0, negative 1, 0, and 1. That's the cosine graph, okay? When does cosine become 0? For what x values does the cosine become 0?
Pi over 2.
Pi over 2 and 3 pi over 2. These are the places where the value of the function becomes 0, right? What's cosine pi according to this graph? It's down here, right? Negative 1. What's cosine 0? Positive 1. What's cosine 2 pi?
Positive 1.
Positive 1. Okay. See, the value of the function is the height, right? So if you're up here, it's 1. If you're right on the x-axis, the value of the function is 0. If you're down here, it's negative 1, right? So if we're looking for when cosine of x is equal to 0, the answer would be pi over 2 and 3 pi over 2. Okay, so let's try to approach the second question in a similar way. Tangent of x, if you write this as a fraction, it's what over what? Tangent is sine x over cosine x. Okay, so when is this undefined? When the denominator is 0, it's undefined, right? So, again, if cosine of x equal to 0, the above is undefined. But we already know when cosine x is 0. We already did that here. So the answer is pi over 2 or 3 pi over 2. Okay, what about the cotangent of x? Cotangent is 1 over what? Cotangent of x is 1 over tangent, which means it's the reciprocal of tangent. Since tangent is sine x over cosine, the reciprocal would be cosine over sine. You flip top and bottom. If you take 1 over something, you flip top and bottom, right? So that's your cotangent of x. Which means this will be undefined when, what is 0? When sine of x is equal to 0, right? We'll make cotangent undefined, right? So now you have to draw the graph of this sine function. 2 pi, pi, pi over 2, 3 pi over 2. If you draw this many, many times, it'll look very easy. So these are the places where the value is right on the x-axis, right? So what are the x values that will make sine x equal to 0? X equal to? 0 and then pi and then 2 pi. That's the sine graph, right? Now pi over 3 in degrees is? Pi is 180 degrees. So if you divide by 3, what do you get? 60 degrees. Okay. Pi over 2 is 90 degrees. 60 degrees belong to the first quadrant, right? Each of these quadrants have 3 sticks. There are 3 sticks here, 3 sticks here, 3 sticks there. Of these 3, first, second, third, which one are we looking at 60 degrees? Third one, because it's 30, 45, 60, right?
Yeah.
So we're really looking at this guy. Okay. All right, so what's the answer?
Radical 3 over 2.
Yes, because that's the large guy. Okay, so the large value is radical 3 over 2. Okay, secant. Secant is 1 over cosine, yes. So let's try to get the cosine pi over 4. That's the cosine graph. And pi over 4 is 180 degrees divided by 4, which is 45 degrees. So divided by 4 is half and half. Half of 180 degrees is 90 degrees. Half of 90 degrees is 45 degrees. Okay. So you have 45 degrees, which means, again, it's in the first quadrant. 3 sticks. 1, 2, 3. Which one?
2.
The second one, okay? What's the length? Square root of 2 over 2. All right, so that's going to, this, we know that because we were looking at this middle one, and this is the medium-sized one, right? Medium size is this. So you're going to say that this is going to be 1 over square root of 2 over 2. And when you do 1 over a fraction, that's the reciprocal, so it flips upside down. And then you have to multiply square root of 2 top and bottom, which gives you 2 times square root of 2 over 2. But 2 and 2 cancel, so you get square root of 2 as the answer. Okay, what about tangent of 225 degrees? This would be sine of 225,
Over cosine.
cosine of 225. Okay. You should try to draw these graphs again. Just keep drawing these 2 graphs until it's just so easy for you, okay? 225 degrees is more than 180 degrees, but less than 270 degrees. So it's in quadrant 3. It's right here. So you think about 3 sticks here. Again, in quadrant 3, you think about 3 sticks here. And see, any special angle that ends with 5 is a multiple of 45 degree ones. Okay?
So just 1.
Yeah, at the end it'll be 1. Yeah. So the multiple of 45 degree ones means it's the middle guy. Okay. So it's the middle guy here, and then middle guy here. So they're both medium size. They're both going down, so they're both negative. So that means it's going to be negative radical 2 over 2 divided by negative radical 2 over 2. And anything divided by itself will be 1. That's how you get it. Okay, now this looks challenging. You have 480 degrees. That's beyond 360 degrees. So what do?
Subtract 360.
You subtract 360 because, see, the values of sine and cosines are tied to the unit circle. So if you go full circle and go some more, it's as if the full circle didn't do anything. The value of the sine cosines repeat every 360 degrees. So if you take 480 degrees, subtract 360 degrees, you're going to end up with 120 degrees. So this will be, this thing cosine 480 is same as cosine of 120 degrees. Okay, let's draw the cosine graph again. 2 pi, pi over 2, 3 pi over 2, cosine graph. And 120 degrees is just a little bit over 90 degrees, 90 plus 30 degrees, right? So 120 degrees is right here. Okay, so what's the value? Compared to the other guys, it's small, right? Negative 1 over 2. Or negative square root of 1 over 2, but square root of 1 is 1, so that's the answer. Okay, cotangent 5 pi over 3. We know that cotangent is the reciprocal of tangent. Since tangent is sine over cosine, cotangent will be cosine over sine. So we have to do cosine of 5 pi over 3 divided by sine of 5 pi over 3. Let's draw the graph of the cosine. And graph of the sine. Okay, what is 5 pi over 3? 5 pi over 3, because pi is 180 degrees. What's 180 divided by 3?
60.
60 degrees, and 5 times 60 is 300 degrees. Okay, 300 degrees is 30 degrees more than 270 degrees, which is this guy here. 270 degrees plus just a little bit. So this is the place that we were looking at. This is the place that we were looking at. Okay. So now let's try to figure out the values. First, the cosine. What's the value of the cosine? What is it?
I want a new room.
Compared to the other two, what do we see? It's small. So what's the value? Positive 1 over 2. Okay. How about the sine? But it's also going down, so negative radical 3 over 2. Multiply top and bottom by 2, you get negative 1 over square root of 3. After multiplication by 2, top and bottom. Times 2, which cancels the denominators. And then you have to multiply square root of 3 top and bottom to rationalize the denominator. And the final answer would be minus radical 3 over 3. Okay, cosecant is 1 over sine. Okay? And because pi is 180 degrees, this is 11 times 60 degrees, which is 660 degrees. Oh no, what's that? That's 3, you have to subtract 360, so this
Just going to be 300.
it will be 300 degrees again. Okay, so this over here will be same as 1 over sine of 300 degrees, because 300 degrees and 660 degrees are coterminal angles. They point to the same place on the unit circle. Okay, but we already know sine of 300 degrees. It's this guy, right? Negative 1 over square root of 3 over 2. Well, it's this one, but we can pull the minus in front. And 1 over the fraction is reciprocal, so it's 2 over square root of 3. Now you multiply radical 3 top and bottom. That gives you negative 2 radical 3 over 3. The value of sine, and you have to find the value of the other trig functions at that angle. Now, if such a question should make use of the reference triangle because in quadrant 3 this angle theta must be somewhere here, and then you can draw some kind of reference triangle that would match with this. But that kind of calculation, trying to make sense of this kind of calculation is quite involved. So I'll just skip through this one and give you a method that works, okay? But if you fully realize how to do this method, then you can kind of backtrace and make it work with the reference triangle. But I'm not going to do that because of lack of time. So here's what we're going to do. First, ignore the negative. And just set sine of theta as negative, just positive 3 over 4. Now convert this into a triangle. If you have an angle where the sine is 3 over 4, remember SOHCAHTOA, right? SOHCAHTOA says sine is what over what? Okay, so what should I put over here?
4.
What should I put over here? 3. If you do that, if you put the 3 on the opposite of this angle theta and 4 on the hypotenuse, then this picture perfectly describes this situation where sine theta is 3 over 4. Do you agree?
Yes.
Okay. So that's what you do, and then you're going to figure this out by using the Pythagorean theorem. So since this squared plus this squared is equal to 4 squared, if you do 4 squared minus 3 squared and take the square root, that will be this length. 4 squared is 16, 3 squared is 9, 16 minus 9 is 7, so square root of 7 will be this length. Okay, now that we have this, apply the cosine of theta. What is cosine theta then? Cos adjacent over hypotenuse, so what over what? Radical 7 over 4. Tangent theta?
Square root of, no, it's 3 over
3 over square root of 7. Okay? Of course, you have to rationalize the denominator, so let's multiply by square root of 7 top and bottom, which gives you 3 radical 7 over 7. Okay. Now, use all students take calculus. Okay. Hopefully you know the way we describe quadrants. This is called quadrant 1, this is quadrant 2, this is quadrant 3, and quadrant 4. The question says the angle is in quadrant 3. So you're right now here, and you see the letter T. What does this T mean?
Tangents
Tangents positive, but sine and cosines are negative, right? Okay. What does this A mean? All. Sine, cosine, tangents, everything is positive. S means sine is positive, cosine is negative, tangent is negative, right? So because we're in quadrant 3, we know that sine theta is really not, it's not 3 over 4, it's negative 3 over 4. Cosine theta is also negative square root of 7 over 4. And tangent theta is positive 3 radical 7 over 7. Okay? Because tangent is positive, the others are negatives, this is what you have. Alright? Now we have to figure out cosecant, secant, cotangent. What's cosecant? 1 over sine. So you take the reciprocal of this, which is negative 4/3. What's secant? You have to take the reciprocal of this, which is negative 4 over square root of 7. Again, you have to do the rationalizing thing. You're going to get this if you rationalize. And then cotangent theta is 1 over this, but it's easier to flip this guy, right? If you flip this guy, that's square root of 7 over 3. And that's how you do it. Okay, cosecant theta is 5. What does that mean for sine? What's the relationship between cosecant and sine? They're reciprocal, so it's going to be 1 over 5, okay? Now think about the picture that would describe this. Here's 5, here's 1, here's theta. Okay, what's this length then? 24, because 5 squared minus 1 squared equals square root of 24. Now it's important to simplify this. 24 is 4 times 6, so 4 comes outside as 2. Okay? So you can now just replace this by 2 times radical 6. And we're now able to write the other ones. Okay, so now what's cosine?
It's going to be 1, oh no, 5 over
2 over 6 over 5.
What am I doing?
What's tangent?
Tangent is
1 over 2.
And then you should multiply radical 6 top and bottom. So radical 6 times radical 6 is 6. 6 times 2 is 12. And then secant of theta will be reciprocal of this, which is 5 over 2 radical 6, which is 5 radical 6 over 12. And then cotangent theta would be the reciprocal of this guy, which is 2 times radical 6. That's how. Oh, but then you have to put the signs. Okay, what's the sign? Minus, 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 and minus, right? Because of the Gaussian state calculus. You're in quadrant 2, so sine and cosecant are positive, the others are negative.